Okay, so how do I take an absolute value function and write it as a piecewise function of two linear functions? Okay, so back in the textbook here, and you did some work like this in my open math, um, I asked you to graph these functions. So what I see about this one here, let me get my pen going. No, I want to use zoom. Here we go. Uh, Annotate. Oh, here we annotate. Okay, good. So suppose I had to graph this one. Well, I see the vertex of that function has been shifted right 2 down 3. And then I see there's a vertical stretch by a factor of 3. So if I had to graph it here, I'm going to come up here and use this graph paper up here. So um, maybe I should use red ink to stand off the blue one. So 2, -3 is here. And then I know it has a slope of 3 because there's just linear functions, and that's how I'm out of space there, so I'll go up and left, up and left, up and left. I think I messed up here. Yeah, I should be here. So that point shouldn't be here. So I've got, let's see, there's a line tool here, isn't there? Here it is. So I've got this graph here. I've got this graph here. Now, the thing I'm doing in that quiz is I'm asking you to take that graph and write two linear functions for it. So I see a graph that's has a negative slope here. It has a positive slope here. And I also see that it has a -3 slope here and it has a +3 slope there. Because of course we knew that because that's what the stretch factor was. And I also see that this has a y-intercept. So this line here, let me come back to my line tool and let me change ink to this pink one. So this looks, I'm gonna have to eyeball this. Probably won't be perfect. I see that line there. Let's see, will it let me move it? I don't know. I don't know if it'll let me tweak that. No. So what I'm supposed to be seeing is there's a slope. That line has a slope of -3 of the y-intercept of 3. So I'm going to write -3x plus 3, and I'm going to use that piece as long as x is less than 2. So it's the x of the core x. So I could say I'm going to use interval notation, not interval notation, but set builder inequality notation. I'm going to say x is equal to 2. So that's going to use that piece. Then I have another function over here. It has so I know the slope is 3x. I don't know the y-intercept, and with this graph paper, I really can't see that. So I know this slope, this equation is y equals mx plus b. I know it's y equals 3x, and I don't know what the y-intercept is. I do know that it passes through the point 2, -3. So I'm gonna just substitute those into my linear function. I'm going to solve that for b. I think I get -7, right? -3 equals 4 plus b. Subtract 4, you get -7. So that y has a y-intercept of -7. And we're going to use that piece when it's greater than 2. I can't have it equal in both places. I won't have a function that way, right? So there's f of x. There's my linear function. So you can get it from graphic. Now, if you didn't know how it looked, graph it, throw it into Desmos and check it out. Okay, but that's what I'm expecting to see for that question on the quiz. Let me clear this out and then I'll do another one that's a little closer to what I'm asking you. Um, Here, erase. I want to erase. Oh, dear, delete all drawings. So now this one here, see how this one was nice. It had the 3 outside. You could see the vertical stretch, but you can get that pretty easily with a absolute value function because if I think about it this way, 3 times x plus 3, I'm just undistributing, I'm factoring out the 3. And then all this isn't this the same as the absolute value of 3 times the absolute value of x plus 3? And the absolute value of 3 is 3. So this is this function, 3 times x plus 3, absolute value plus 3, a lot of 3's here. So this function has a slope of 3. So it'll have on the left, it'll be a -3 slope. On the right, it'll be a +3 slope. And it has a vertex at -3, 3. So thinking about it graphically, -3, 3 is up here. I know it has a vertical. Let's see. So then it stretches up 3. So I know this side it has a slope of 3. This side has a slope of -3. So those look like that. With bigger graph paper, you could probably count that out. But I'm going to be lazy because I don't have that because I know how to do this. I can say y equals -3x plus the y-intercept, and it goes through the vertex -3, 3. So 3 equals -3 times 3 plus b. So that'll be let's see, I'm using -3. Something not right here. Just a minute. This should be -3. X is -3, right? X is -3. So 3 equals 9 plus b. That tells me b has to equal -6. So I've got my first line, I've got a -3x minus 6, and I'm going to use that. I don't know, let's say x is less than or equal to -3, the x coordinate, right? The x coordinate of that vertex. So the left of -3, I'm going to use that line with the negative slope. On the right-hand side, I know it's going to be 3x plus something. And again, I don't see, can't see that on my graph. So I'm going to say 3, which is y, equals +3, which is the slope, times x, which is -3, plus b, and that'll be 3 equals 12, or -12 plus b. So b would have to be equal 15. So plus 15, and I'm going to use that piece when x is greater than -3. And remember, it doesn't matter which one's equal to, we just don't want them both equal to. And there's my piecewise defined function, f of x. Okay, so see if you can't figure this out from the question I gave you on the exam, on the quiz, okay? So there's a lot going on here. There's absolute value stuff. There's linear function stuff from section 2, 1, 2, 2, and 2, 3, and then going back to 1.2 with the piecewise defined functions. Okay, hopefully this gives you the help you need. If you want to meet live and get some help, glad to do that with you too. You just got to grab a time, on that Calendarly site.